Today I'm going to be talking about some of the recent work we've done with Instar and the developments we're making to where we can implement it and incorporate it across the producer fields in the state. First off, I'd like to always thank the Rice Checkoff as well as the U.S. Rice Foundation for supporting this research. We've got some multi-year monies from them to pursue this research, which has been a great benefit. It's allowed us to really make some advancements in the soil test much quicker than we would have been able to do otherwise. The first thing I'd like to do is direct your attention to the plots behind me. As you can see, what we've done is incorporated a validation step into our research, and what I mean by validation is we use the soil test to predict N rates that we feel will maximize yield within a particular situation. And when we go out and apply those rates in producer fields and on experiment stations, and then we see how those yields compare to what our standard recommendation or our standard producer practice might be. Back here, what we have is wells. It's an Instar validation looking at fungicide interactions. We're working with Dr. Cartwright. What we have is, if you're looking from left to right, you'll see we have a 0 N rate plot. We include that just to see what the native soil N would produce without any nitrogen. As you move across, you'll see our 90% relative grain yield curve. That predicted that we would require 90 units of nitrogen to achieve 90% relative grain yield at this location. Essentially what we did there was a 45-45 split. As you move across, the 95% relative grain yield predicted 115 units of nitrogen, and that was simply 45 at mid-season, the rest applied pre-flood. The 100% relative grain yield curve predicted 145 units. We have a single pre-flood treatment where 90 units were applied all pre-flood. And then we have the standard recommendation for wells, which is 150 for wells grown on silt loam soils. And as you can see, there are not a lot of differences in terms of height and color between our 90% relative grain yield curve and the remainder of our treatments all the way up to the standard recommendation. One thing you will notice is the single pre-flood treatment is maybe just a little bit shorter, but in terms of height and color, and eventually when we get grain yield data from this, what we're finding in last year's data as well as many of the producer fields this year is that these lower N rates are able to achieve the same yields that we would get when we apply the standard recommendation of 150 units. A lot of the work that we're also incorporating this year, and like I mentioned, the fungicide interaction study, is to look at when we lower those N rates back to a prescribed amount, are we able to eliminate fungicide applications? And one thing that we've seen here and in Lawrence County and in St. Francis County is there's an obvious relationship between N rate and disease severity. But what we also find is that when we have a site-specific N rate or an N rate that matches a producer field, the disease severity starts to disappear. And what we're hoping to find is that when we have a site-specific N rate, that will eliminate some of the need for these fungicides. Because as we're over-applying nitrogen, we're increasing the severity of our diseases in our fields. One thing I'd like to move on to is, when are we going to actually get this test implemented? There are a few more little key steps that we need to do. The key points that I would like to let you all know about today is we want to do limited release for silt loam soils next year, the spring of 2011. So if you have producers or if you yourself are interested in doing some of this work or implementing the soil test for your silt loam fields, you need to start letting us know now so we can get a sampling protocol to you, get those soil samples analyzed, and get a rate recommendation for you. We're still working on clay soils. It's been a little bit more difficult. A couple of the things that we have found is that for the silt loam soils, you have to sample 18 inches deep. For the clay soils, we found that the rooting depth on clays for rice is somewhat shallower, and we'll only have to sample clays 12 inches deep. And some of the preliminary work that Dr. Slayton and I have done on wheat has shown that wheat rooting depth is even shallower than that, and the soil test for wheat will only require a 6-inch sample depth. And one of the things that we've done to try to combat this deep soil sampling problem, I know there were a lot of people concerned about taking 18-inch soil samples. What we've done is kind of developed a hybrid soil sampling device here that will allow you to take 18 and 12-inch soil samples somewhat quickly. And all it is just a Lowe's bucket modified with a plate and a pipe. I'll give you the mic here real quick so I can show them this. But essentially all it is just a steel plate with a piece of pipe in it. And all you're going to do is set this on the ground, and we have some stops that are being made that will allow you to set the depth you want to sample. So for a silt loam, your stop would be set to sample 18 inches deep. For a clay, the stop would be set to sample 12 inches deep. And then for wheat, you could just use a standard like Oakfield push probe to sample that depth. But what's nice about this particular setup is you can take an 18-inch soil sample in a matter of a few seconds. And what it does is just collect the soil sample in the bucket, and an 18-inch soil depth will fit in a standard soil test box. The little white soil test boxes. An 18-inch soil depth will fit in one of those standard boxes. Some of the key things to utilizing this soil test, the main one being we really have to be careful about our pre-flood nitrogen management. And one of the reasons for that is we are giving you a rate that's going to maximize your yield, but it's also a very precise rate. And one of the key things we need to relate to people is that there's not a lot of room for error there in terms of nitrogen loss. So we really have to be able to manage our pre-flood nitrogen very well in order for this test to work. And that always brings up the issue of nitrogen loss and ammonia volatilization. And so some of the things that we really have to push along with the incorporation of this soil test is the use of urease inhibitors to prevent ammonia volatilization pre-flood. Currently, we're testing a lot of different products. In the field now, we have a study looking at a new product that hopefully we'll get some results on this fall. But the one thing I would just mention is that currently, Agritane is the only urease inhibitor that is recommended for use pre-flood on urea fertilizers in the state of Arkansas. There are a lot of other products out there, but currently none of them have the results that would warrant us really supporting them for pre-flood fertilizer use.